We're going to look at the Chapter 5 review. And the problem starts out with number 1. And by the way, those of you who are taking an online test from the face-to-face class, I edited yours and it only has 20 questions instead of 25. But those 20 will be like 20 of these. I'm just not going to tell you which ones I took off. All right, number 1, I'm not going to write the instructions on this video review. Evaluate the expression with the given values. And it says, what is q to the 5th when q is equal to -3? Okay, so I'm supposed to evaluate this. That means I'm going to put -3 in parentheses, raised to the 5th power. If I have a negative base and I'm raising it to an odd power, that means that I'm going to have an odd number of negative factors. What sign will the answer have? A negative. And then if you say, let's see if we can do this, 3 times 3 is 9, times 3 is 27, times 3 is, somebody do it, pardon? 81, yes, 81, and then times 3 is 243. I think my screensaver came up in my brain and I couldn't think for a minute. All right, so it's 243 and it is negative. Be sure you have your calculator so that you won't make a silly mistake like I almost did. Then it's stated differently in the second question. It uses capital Q as a function of x, which we have done almost no work with, but we do know how to do these. If Q of x is -3 x to the 2nd minus 5x minus 9, find Q of 4. Find Q of 4. -4, thank you. So Q of -4, what does that statement right there tell me to do? Replace the x with -4 everywhere you see an x. So it's -3 times -4 in parentheses squared minus 5 times -4 minus 9. Question?
Why did it become negative?
Because I copied the problem down wrong. Okay? Yeah. There is a tiny negative which my very mature eyes did not see. All right. When you're evaluating this, order of operations comes into play. Good old Aunt Sally is back with us. And she says to do exponents before you multiply. So I'll keep the -3. And what is -4 squared? It is 16 and it's positive. And that's the only step I'm going to do.
Question.
Yes.
If you're doing them, please excuse my dear Aunt Sally.
Yes.
P is first. So you would do parentheses. Oh, there's nothing inside the parentheses.
Okay. It was a very good question and very nicely answered. And I didn't even have to get involved. All right, so -5, parentheses, -4, minus 9. And some of you will do multiple steps in one line, but I'll just do one. That gives me -48. The next term, -5 times -4 is +20 minus a 9. And that's going to be, I've got -57 plus a 20, 28. Duh. Did y'all get negative? Oh, no, wait. -48 and a -9 gives me -57 plus 20. Did y'all get -37?
I didn't know.
You might want to check and make sure it's the right answer. So please, when you sit down to take your online test, make sure that you have paper and pencil and that you're treating each question just like you would if it were on a printed test sitting in front of you. You do your work, you check it and so on, you submit an answer. Until you actually submit the test, don't submit an answer, that was bad phrasing on my part, you'll just go to the next question. You submit at the end. The very, very end. Until you hit submit, anytime in that 120 minutes, 2 hours, you may go in and change one of your answers. So you can check things. It is multiple choice, and so that gives people a lot of confidence, because if you get negative 37 and you look and it's an answer choice, what is the chances of you doing it wrong and getting one of those answers? Well, you do have to be careful, because they will sometimes make common mistakes and let those be answer choices. So it's not a given that if you got an answer that was there, it's the right one, but it makes me feel better. All right, next group. You're going to use your properties of exponents. And I will make a notation on this paper as to which property I'm using. All right, the first one says that all the instructions say simplify using the properties. Okay, I have 3x in parentheses times 4x to the third parentheses times x to the 7th. The properties are on your blue sheet, on the notes that could be printed, on the handouts for my online people, and you should do the properties in this order. Power rule, product rule, quotient rule, negative exponent rule, and then if you have 0 as an exponent, you can do it anytime. This is the order that they're listed on the blue sheet, so you don't have to memorize this order. That's the order they're listed. All right, looking at each one of these, do I need to use the power rule? What's the power rule? How are you going to know? You're going to have some parentheses with a power up here on the outside. Do you have that? No. Product rule. You're going to use the product rule if you have like bases being multiplied together. Do you have like bases being multiplied together? Yes, so I'm going to choose the product rule. And I really want that red. What's the chance? Yay. The product rule is being used. All right, the numerical coefficients, the numbers, just multiply them together. So what will be the coefficient of this answer? 12. Now, I have x times x to the third times x to the 7th. What does the product rule tell me to do with all of those exponents? Add them. What is the exponent on this one? 1. So I'm going to add 1 and 3 for 4 and 7 for 11. This is times x to the 11th power. And I use the product rule. By the way, the quotient rule is going to have something up here and something down here. And you know what the negative exponent rule looks like. There'll be a negative exponent. All right, let's look at number 4. I need to simplify 40 m to the 6th n to the 10th over 8 m to the 5th n to the 8th. The list of rules. Do I have anything calling for the power rule? No.
No.
Do I have a product of like bases? No. Do I have a quotient of like bases? Yes. Here's a quotient. Here's a quotient. So I'm going to use the quotient rule. All right, with the numerical coefficients, all I'm going to do is divide. 40 divided by 8 is 5. Now the m's. I'm going to have a power of m here. What do I do with the 6 and the 5? Subtract. So I get a 1. 6 minus 5 is 1. What do I do with the n's? Subtract. 10 minus 8 is 2. You will not see an answer written exactly like this. How will you see it written? Yes, 5m n to the second. Number 5. I need to simplify the base -5 in parentheses raised to the 0 power plus -3 in parentheses raised to the 0 power. Okay. Any base except 0 to the 0 power is 1. So that one's equal to 1. That one's equal to 1. And now finish it up. Add them for 2. You can, anytime you see a 0 exponent, you can jump into it immediately and say, I'm replacing that with 1. Any base to the 0 power is 1. The exception is 0 to the 0 power, which is undefined, and it will not come up on your test. Number 6, still using the properties. I have 5 to the 3rd raised to the 6th. Okay, the properties. Do I need to use the power rule?
Yes.
Yes, I do. And I can tell because I have these parentheses with the power on the outside. What goes on between these exponents when I'm using the power rule? Multiplication. So I'm going to have 5 to the 18th. And you will not be asked to expand that to its standard form because it would be tremendously large. Number 7, I have p to the 3rd over p to the -7. Now I know that -7 is screaming at you, going, oh my goodness, please move me. But tell it to be quiet for a minute, because you could do that. It wouldn't be wrong. But the way that I suggest that you do it is, do I need to use the power rule? Do I need to use the product rule? Do I need to use the quotient rule? Yes. So I recommend that you use the quotient rule first. And then if you've done that and you still have a negative exponent, then you change it. And by the way, I didn't write the property up on this other problem. Did I write it on previous ones? Nope. There we go. All right. Y'all told me it's a quotient. What do you do with the exponents when it's a quotient? Subtract. So you take the numerator exponent, you put down your subtraction sign, and you write down the denominator's exponent. And I can't tell you how many people just combine those and say it's -4. But if you did that, you used addition rules to get that. You need to subtract. What happens when you have a minus? You end up doing plus, plus, plus. So this becomes p to the 10th. Do I have a negative exponent? Nope. I don't now. Now I don't have to worry about it. Could you have moved it? The answer is yes, but it would have taken 2 steps to finish the problem. Do you want me to show you that way? No. Okay. Then I won't. Number 8. I have a lot of things. 4 r to the -1 times r to the 2nd raised to the -2 all over 7 times r to the -1 raised to the 2nd. Okay, this is the question on the review that requires the use of multiple rules. So, which rule do I recommend that you use first? Power. Do you have any need of the power rule? And my answer would be yes right here and yes right here. Both of those indicate the power rule. So I'm going to copy down 4r to the negative 1. What do you do with the power rule? What do you do with the exponents? You multiply them. So I'm going to get r to the negative 4. Positive 2 times negative 2 is negative 4. And I'll put a multiplication dot in there because I have dropped off the parentheses. The bottom, I have 7. What am I going to get for a power of r?
Negative 2.
Negative 2. So there I used the power rule. All right, now look at what we've got. In the list, after the power rule comes it doesn't come yet next. The product rule comes next. Do you have a product of like bases? Then I encourage you, although it's not a rule, I encourage you to do that next. So that'll be 4. When you're going to multiply those, what do you do with the exponents? You add them. So when I'm using this rule, I'm going to add those two exponents, and that's going to be r to the negative 5 over 7r to the negative 2. So let me make a little note. We use the product rule. What comes after the product rule in the list of order? Quotient. Do I have a quotient?
Yes.
Yes, I have this way. What do you do when it's a quotient? You subtract. Now, I'm going to leave my 4/7 because I can't do the division here. And then I'm going to put r to what power? Well, I'm going to write it out. It's negative 5 minus negative 2. But when I have minus minus, I change them to plus. What is negative 5 plus 3? Negative 3. So this is 4/7 r to the negative 3. Now, I would say that you might have a question right now because definitely this base is screaming at us, please move me. Where is it? Where should it be sitting? Because I dropped it out of the fraction. Oh, let me put it back in. It will go back into the numerator. That's where it is right now. By putting it back there, that makes it a little bit easier to recognize that that's what moves, and it moves down. That now gives me 4 over what? 7 r to the positive 3, because it moved. So I used the quotient rule, and then I used the negative exponent rule. I used everything except the 0 exponent in this problem. Used every single property. When you do a quotient and you get just the r to some power, it is a numerator factor. It is in the top. That's what I showed you right there. Okay, are we sort of okay on the properties? Here's the list of properties. You need to be able to identify which one you need to use. You notice the questions don't say, use the product rule, use the so-and-so rule. Okay, we'll go ahead and go on. Let's look at number 9, changes things. It says, write in scientific. Okay, write in scientific notation. This is that small and large thing. All right, the number that they give me is 63,000. That's what's written. Okay, if I'm going to switch it to scientific notation, where will the decimal go? Do y'all agree it'll go right there? So I'm going to have 6.3, and I don't have to put those zeros. And it originally started back here, so it will have moved 1, 2, 3, 4 places times 10 to the 4. Should that be a positive 4 or a negative 4?
Negative.
Okay, what's the rule? It's a positive because it's a big old number. Okay, so big number, positive exponent. If this had been 0.0059, then the exponent would have been negative because it would have been a tiny little decimal. Let's look at 10. This one says to write in standard notation. And the number they give us is 1.929 times 10 to the negative 5. Now this is scientific notation. What does this exponent tell you?
It's going to be a little number.
It's going to be a little number, and the little number is going to be a decimal type number. So I'm going to need to move the decimal point how many places? 5. So I'll move it 1, 2, 3, 4, 5. I'll drop it there, and it will become 0.0001929. And you could check. Did it move the same number of places as the exponent? Is it the right size? Yes, it's a tiny little number and it had a negative exponent. Positive means a big old number. Negative means a tiny decimal. So there will only be one question moving from scientific to standard and one from standard back to scientific. Okay? Now, the next 3 questions, and there probably won't be 3 of these on the test. There's really no need. It says to perform the indicated operation. All right, number 11. The indicated operation on this problem is addition. It has parentheses, 4x squared minus xy minus y squared plus parentheses, x squared plus 7xy plus 3y squared. When there's a plus sign, what does that tell you about the parentheses? Do they change anything? Do they really even matter? The answer is no. It's as if this one is preceded by a positive 1. So if you multiply, that's the identity. This is preceded by an imaginary 1. So that's the identity. So nothing changes. You can ignore the parentheses. So now, if I'm going to add, what kind of terms am I looking for? Like terms. Do y'all agree that those are like? This is my chance to be colorful. And those are like? And my favorite one. Those are like. I was so surprised this semester in one of my other classes. I had a student who had told me that she always had learning disabilities, that she couldn't, it was a vision thing. What she saw just wasn't connecting right, and she had a lot of trouble. The color made all the difference in the world. All of a sudden now, it's like the light bulb just got turned on. And bless her heart, she carries multitudes of colored things with her now. I mean, it looks like an art table when she's setting up, because in her notes, she color codes things, and that way her eyes actually connect things. So It's not just that I like the pretty colors. It's actually educationally sound, but I do so like the colors. All right, if I add my nice little turquoise ones, this x squared terms, how many will I have? I have 4x squared here, I have x squared here, which means how many? I have 5x squared. And don't forget, you're not using one of those rules. You're just combining like terms, which means you're adding and subtracting the coefficients. All right, now the xy terms. How many xy's, or what's the coefficient in the first one? -1. So it's -1, and that's +7, which means it is 6xy, positive. Lastly, I have, again, a -1y squared. I have a +3y squared for how many? 2y squared. Are any of these now like terms, or have I done everything I can do? That's it. Because to be like terms, you have to have the identical letters with the identical variables. And I'm done. Whoops. Number 12. I have 8y squared plus 11 minus, parentheses, -8y to the 4th minus 4y squared plus 11. Yes, sir. Everything changes after the negative sign, after the subtraction. It's just like you distributed a -1. But what I'm going to do is say, okay, we can ignore this, make it be a plus, if I change that sign, and that sign. Okay, so now I can ignore my parentheses, and let's see. Here's the largest powered term. Does it have any matching friends? No. Here's the next highest, and it does have friends. And then there is the constant, and there's constant friend. All right, now, we like to write our polynomials with the highest degree term first. So what will I write down first? 8y fourth. That was first, had no friends to join up with. Now, there aren't any y to the thirds, but y to the second. I have a +8y to the second. I have a +4y to the second, which is 12y to the second. Next, I have +11 and -11. They cancel out. So we don't have a constant in our answer. This is the difference between those two. All right, number 13. I'm going to go ahead and write it down, even though this is going to take a minute to get all this written down. It says, subtract 3x minus 30 from the sum of -2x plus 4 and 9x minus 14. I know we did one of these in class notes. I'm sure you had one in math lab. What do you do first, and why do you do it first?
Switch it.
All right, you switch from the way it's written. It says subtract, but I don't do that first because it says subtract from, which is a reversing phrase. So I need to put down, -2x plus 4 plus 9x minus 14. I need to find that sum, and then I need to subtract from it 3x minus 30. So in this problem, you have to be so careful about the order, but the words are supposed to communicate that. It says subtract from, which is a reversing phrase. That means that whatever you're supposed to subtract this from goes first, and you put that at the end. Now, Do I really have to do the addition before the subtraction? I really don't have to. I could just go ahead and, well, I will. Algebraically, I ought to. Some of us would cheat and do a couple of things at once. If I find this sum, which I don't have to change anything, what is negative 2x and positive 9x? 7x. What is plus 4 and minus 14? Negative 10. And then I write down minus parentheses 3x minus 30. What should I do next? Change the signs because it's subtraction. Change it to add, opposite, opposite. Now I can ignore those parentheses. I have a positive 7 and a negative 3x for 4x. I have a negative 10 and a positive 30. Positive 20. And I'm done. So there were several things in that problem. You had to recognize what subtract from says to you, and then perform the addition, perform the subtraction. All right, there's an entire next group of problems that are all under the heading multiplication or multiply. That's a very weird Y. All right, number 14. I have 10x to the third times 5x to the 6th minus 10x squared plus 11. We learned a lot of different things when we were multiplying. What kind of property are you going to use when you multiply this? What kind of multiplication will we do? Distributive? Because we have just this one term out here, so I need to distribute it. I'm also going to use, with my exponents, the product rule, because I am multiplying. So 10 times 5 is 50, and I'll get x to the, what do you do with the exponents when you multiply? Add them, so it'll be 9th. Then I multiply 10 times negative 10 for negative 100, x to the, what power? 3 plus 2, 5. And then finally, 10 times 11 is 110. I don't have any x's there, so I just keep x to the third. Distributive property is a form of multiplication, and it tells you to add the exponents. Is that okay? All right. 15. I have x minus 11 times x squared plus 3x minus 2. Well, this is a binomial times a trinomial. I'm going to have to use distributive property here, and I've got to do it twice. So the first thing I'll do is distribute the x to every term. When I'm done with that, I will distribute the negative 11 to every term. My preference is to write it down sort of in order as I go along. It's been a few days since we've done these. When I multiply, don't forget, you're still using the product rule. All right, x to the first, which is the plain old x, times x squared gives me x to the third. What is x times 3x?
3x squared.
3x squared. Yes, add those invisible ones get added together. And then what is x times negative 2? Negative 2x. I have 3 of the 6 terms I'm going to get. That was through the red distributive property. Now I'm going to use the green distributive property with negative 11. Negative 11 times x squared gives me
Negative 11x squared.
negative 11x squared. Now, why did I choose to write it where I did?
Because there
because those are like terms, so I might as well line them up. It's better than having it drag way over here. All right, negative 11 times 3x gives us negative 33x, and I can put it under the x term. Then negative 11 times negative 2 is positive 22. Negative times negative. So my like terms are in columns. The final answer will be x to the third. What do I get for my x squareds? Negative 8x squared. That was positive 3 and negative 11. For my x's, negative 35x, and bring down the 22. Do y'all need that up there longer? Are we good? All right, let's go to 16. I have 2x plus 5 times x minus 11. Pardon? FOIL. I was about to say, what kind of multiplication do we use when it's a binomial times a binomial, and the answer was FOIL. So I did 2 problems where I used distributive property, and now I'm going to use FOIL. Now, because this is a review, I'm writing all this out, and I hope that you really don't need to. What's the product of the first? 2x times x, and I heard it, 2x squared. The outer product is how much? Negative 22x. The inner product is 5x. So, for those of you who have mastered the shortcut, you've already gone ahead and added those together for negative 17x. What's the product of the last? 5 times negative 11. Negative 55. The final form of my answer is 2x squared minus 17x minus 55. All right, 17. Was everybody through with 16? Are we good? Okay. Number 17, I have parentheses, x minus 4y times 2x minus 4y. What technique of multiplication do you think I want to use? FOIL. Okay, I'll do it again. What's the product of the first? X times 2x. 2x squared, because I use the product rule and I add those exponents. The outer product is how much? X times negative 4y. Negative 4xy. Always the number first and the letters in alphabetical order. X then y. What's the inner product? Negative 8xy. No matter what order the letters are in up there, they need to go into alphabetical order when you multiply them. And what's the product of the last? Negative 4 times negative 4 is positive 16, and y times y is y squared. I didn't pause and do it this time, but can you combine your inners and outers? Yes, so I'm going to have 2x squared minus 12xy plus 16y squared. Is that okay? All right. Number 18. I've got to work on my spacing. I always make it just wrong, and anyway, it's bothering me. All right, number 18, I have 10x plus 3y quantity squared.
Multiply twice.
Okay, 2 ways to do it. The way that tends to stick in everybody's head is write it down twice, and I'm just fine with that. You're going to multiply the first for 100x squared. The outer product is 30xy, and the inner product is 30xy. So I'm going to move this down a little bit. 100x squared. What's going to be the sum of 30xy and 30xy? 60xy. And what's the product of the last? 3y times 3y. 9y to the second. Okay? Now, that was doing it by FOIL. Absolutely fine, nothing wrong with it. But we did learn how to square a binomial. If you have 10x plus 3y quantity squared.
That's synthetic? Is that-
No, this one's not synthetic. This was just a shortcut. We had that whole day of shortcuts. You square the first. 10x times 10x is 100x squared. You multiply the two terms for 30xy, but you have to double that because that represents the inners, but there are also outers, and they're the same. So double it by multiplying by 2, and you get 60xy. Then square that last one for 9y squared. Did I get the same answer? And it's yes. What was really different was that up here, I have 30xy and 30xy written down twice. Down here, I just wrote it once and remembered to double it. You can use that if you want or not. Today in class, in my 311 class, we had to go back and review squaring binomials for the lesson we were doing. So you can live a happy algebra life doing it this way. But there will come a point in time where you're going to need to be proficient at this. And if you're in my class, then I'll remind you about it at that time. Number 19. So am I going to have some of y'all in intermediate algebra as I talk? Okay, sorry, little digression. Number 19. I have 9p plus 11 times 9p minus 11. Okay, you can use FOIL. 9p times 9p gives me 81p squared, and it's very common to see people leave off that square. You won't have that as an option because you'll be checking off a multiple choice answer. All right. Look at the outer product and look at the inner product, and what do you notice? They're the same except for signs. In other words, they're opposites. And what happens to opposites? Cancel out, so I don't need to write any of that down. Negative 99p and positive 99p cancel. This is a sum and difference product. It's one of those shortcuts. What's the product of the last? Positive 11 times negative 11. Negative 121. Do you remember this kind? It's a sum and difference. And what happens with the sum and difference? Outers and inners always cancel. So you don't have to waste any energy on them. But if you do waste some energy, it'll be okay. Number 20. I have x plus 2 times x minus 2 times 3x minus 10. How hateful was that? To make up a problem with 3 factors. Not really. Not really hateful. Because if you multiply these two together, because they come first, do you notice that that's a sum and difference product? So let's multiply those first. And whatever I get, I'm going to put in parentheses so that I can then multiply it by 3x minus 10. So what's the product of the first? X squared. What about the outers and inners? They cancel. The outer product and the inner product cancel, so I don't need to worry about them. What's the product of the last? Minus 4. Now, the reason that this was not such a terrible problem is because it was created with this sum and difference, which means I still have a binomial times a binomial, and I can still use some FOIL. So, what's the product of the first? X squared times 3x. 3x to the third power, using the product rule, adding the exponents. What's the outer product? Negative 10x squared. What's the inner product? Negative 12x. And what's the product of the last? Plus 40. This was an exception to the rule that says usually outers and inners are like terms. But they're not, are they? No. This problem is finished. My answer is 3x to the third minus 10x squared minus 12x plus 40. And I perhaps need to pick up my pace. Number 21. I'm going to divide, and this is division by a monomial. The problem starts out as 30x to the 6th plus 30x to the 4th plus 42x to the 2nd all over 6x to the 4th. Division by a monomial. This is supposed to be the easy kind. Separate it. This is 30x to the 6th over 6x to the 4th, a little quotient, plus 30x to the 4th over 6x to the 4th, plus the final quotient, 42x to the 2nd over 6x to the 4th. I'm going to use the quotient rule 3 times. For the first one, what's 30 divided by 6? 5. X to the 2nd, because I took 6 minus 4. So I used the quotient rule and subtracted. Plus, 30 divided by 6 is 5. Now, using the quotient rule, I get x to the 0. What is x to the 0?
1.
So should I have 5 times 1 written down? That should be gone. Another way to think of it is that divided out with that. Gone. Don't put an x, because an x means x to the first. All right, plus 42 divided by 6 is 7. And if I subtract, do y'all agree that I get x to the negative 2?
Yep.
So I'm going to do what with that? I'm going to, please move me. That gives me 5x squared plus 5 plus 7 over x squared. Done. None of those are like terms. And by the way, that's not even a polynomial anymore because it's got an x in the denominator. But don't worry about that. All right, 22 is long division, and I'm going to divide x minus 7 into 3x squared minus 13x minus 56. All right, so I take a look at first term. What would you have to multiply x by to turn it into 3x squared?
3x.
I need a 3 and I'd need an x to increase its exponent. So now do it. 3x times x is 3x squared. 3x times negative 7 is negative 21x. What happens next? Change the signs because I'm doing subtraction and I always change the signs on the second polynomial. Those cancel as they always should. And what will I get here? I'll get 8x. And I bring down the next term, minus 56. And I start my little question over. What would I have to multiply x by to turn it into 8x? 8, so put a plus 8 at the top. 8 times x is 8x. 8 times negative 7 is negative 56. Time to change the signs. That becomes minus, that becomes plus. I have a 0 remainder. The answer choice that will be right would be 3x plus 8. Could you check it if you wanted to?
Yes.
Multiply using FOIL, 3x plus 8 times x minus 7. (23) The problem is x squared minus 64 divided by x minus 8. It was important that I write that down because we're going to have to do some division. We're going to do division, but we've got to add a term. Does everybody notice that there's a gap here? So I'm going to divide by x minus 8, and I'm going to divide into x squared plus what? I need 0x minus 64. And this is the issue that you have to be so careful about. It's missing from in here. It goes from x squared straight to the constant, and I need a placeholder. We had a discussion about that, but it's kind of easy to forget. So now I start over and I compare. What do you have to multiply x by to get x squared? X. X times x is x squared. X times negative 8 is negative 8x. Change my signs, minus, plus. Those cancel. I have 8x, and I bring down minus 64. Do my little comparison again. What do you have to multiply x by to get 8x? 8. 8 times x is 8x. 8 times negative 8 is negative 64. Change again, minus, plus. Cancel out, no remainder again. Your answer is x plus 8. The last two problems are synthetic division. So I'll copy down the problem. It has x squared plus 2x minus 80 over x minus 8. If you're going to do it synthetically, no x's show up in the problem. What are you going to divide by? 8. Do you remember that this is where and the only place that you do your sign change? All right, now I write down the coefficients with a little bit of space. The coefficient of x squared is 1. Coefficient of x is 2. The constant is negative 80. I leave a blank and draw a line. What's next? Drop the 1. And now it's multiply, write it down, add. 1 times 8 is 8, add for 10. 10 times 8 is 80, add for 0. What is this number?
The remainder.
That's the remainder. Okay, so I have a remainder of 0. Now I've got to translate this back into polynomial notation. When you look at your answer choices, 1 space 10 is not going to be an answer. But if you remember that if you move from right to left, that the next one over is the constant, and the one after that is the coefficient of x, and if I had another one, it would be an x squared, and so on, building powers. My answer is x plus 10. Plus because it's positive. Okay, 25, last one. On the paper, it shows x squared minus 49 over x minus 7. Synthetically, what are you going to divide by?
7.
Okay, it is a negative 7, so I put positive 7. What are we going to divide into? First coefficient is 1. Second coefficient is, oh good, somebody saw it, a 0, and the constant is 49. What happened here? There's a gap. It goes from x squared straight to the constant. So I need this 0. You need those zeros whether you're in long division or synthetic. Leave a blank and draw a line. Bring down the 1. 1 times 7 is 7. Add for 7. 7 times 7 is 49. Add for 0. That's the remainder. That's the constant. That's the coefficient of x. So what's my answer? X plus 7. And that's the end of the review.